Okay, for what we have in this introductory part that we have concerning stochastic matrices and Markov chains, okay, we're looking at the characteristics of a stochastic matrix, okay, and for a given probability matrix P, okay, this is going to be regarded as stochastic if it has all three of the criteria listed, okay, and the first is that the matrix is square, okay, whereupon we have the number of rows to be the same as the number of columns, okay, and also where we have the entries, that is the probabilities, are going to be non-negative, and also third, we have that the sum of the probabilities for each column will be 1, okay, and so this is the generalized version of probability matrix, and looking at determining which of the matrices will be stochastic. Okay, so we have for the first, okay, we have a square matrix. Okay, so you have 2 rows, 2 columns, and now all the entries are non-negative. And now, so we've got 2 out of the 3 conditions met. However, the sum of each column must be 1. Okay, now, if you notice, the second column we have 1/3 and 2/3 is 1. However, with the first column, okay, we have 1/2 plus 1/4, and that comes out to 3/4 or 0.75. And so this first matrix is not stochastic. Now, for the next probability matrix, okay, we have another 2 by 2. Okay, so you have a square matrix. All the entries here are non-negative. And to be stochastic, okay, the columns must be with the sum of 1. Okay, so first column we have 1/3 and 2/3 is 3/3, which is 1. And then we have 3/5 plus 2/5 is 5/5, which is also 1. And so column number 2, or I should say matrix number 2, is stochastic. Now, for what we have in the third case, all right, now we have just like the first 2 matrices, okay, this probability matrix is squared. We've got 2 rows, 2 columns, and the entries must be non-negative. And guess what? We have -1 inserted. So this third matrix is not stochastic. And then we have for the next matrix, okay, this time, okay, we have 4 rows, 4 columns. So we have another square matrix. All the entries here are non-negative. And now the sum of the probabilities for each column must be 1. So you got 1/4 and 1/8 added to 1/2 and 1/8. Okay, and that will add up to 1. 1/7 plus 2/7 is 3/7. And converting to 14ths, okay, 3/7 is going to be 6/14. Add to 3/14, so we have 9/14. Plus 5/14 is 14/14. So we have that sum at 1. Then we have 1/8 and 5/8. So you have 6/8 or 3/4, and adding to 3/16. Now 3/4 is going to be 12/16. Adding 3/16, we have 15/16, and then adding one more 16th, we have that total at 1. And then we have for the last column, we have 1/10 plus 7/10 is going to make 8/10, which is 4/5. And 4/5 plus 1/5 is 1. So matrix number 4 is stochastic. And in the case of the fifth, okay, now while you have the columns to add up to 1, or I should say the entries per column to add up to 1, the matrix is not squared to begin with. So you have an imbalance between the number of rows, which you had to be at 2, and the number of columns, which is 4, and this is not a square matrix. So the fifth matrix is not stochastic. So out of these 5, only the second and fourth matrices are stochastic.